Alright, so I'm going to start with another apology. I know these are boring. It is not fun sitting in my living room talking to myself about math, so I hope you'll cut me just a little bit of a break. I always made fun of people who did their math YouTube videos, and now I get it. I owe them all a mental apology. Anyhow, this particular lesson is a combo lesson between the Remainder Theorem and the Factor Theorem. They are, in fact, the same theorem with different results. And hopefully I'll be able to explain that to you really well, really clearly. And if not, please get in touch. So basically, if I give you a polynomial, your job is to call it f at x. That gives you the communication tool that will let you sub in numbers pretty easily. So that is the same, and I'm just going to point to it here. That is the same whether you're talking about the Remainder Theorem or the Factor Theorem. Next is you will be given a divisor in either case, and you get to solve for x so that the number that you input into f at x is the opposite or the solution to the divisor when set equal to 0. That is the same here. So when you substitute that number into the polynomial and you get a number that is not 0, it's called the Remainder Theorem because you will end up with a remainder. If you substitute that number in and it gives you 0, that means there is no remainder, which means it divides in evenly, and a fancy way of saying that something divides in evenly is it's a factor, which is why factoring is so important. So I believe this note also goes over some of the older skills, which is why I said when we were doing long and synthetic division that you are given multiple opportunities to learn this over the course of time. Hopefully you are also asking me questions because I'm happy to answer them. So I'm going to hopefully tell you the difference between these with some examples. So here are our first three. So I am going to move a couple of these out of the way so that we don't have, or I have room to do my messy writing. So I'm just going to make myself a page and scoot these two over. Oh, that didn't work. Reminder, you can pause anytime. I think I've given myself way too much room. So the first question is to divide. Now, I'm going to go over long and synthetic division. That way everybody's happy or unhappy. So I'm going to dig out my little pen thing. Remember, be very, very patient with my handwriting as well. I'm going to pretend like we haven't done this except for the fact that it'll be a little bit speedier than yesterday. So here's the dividend. It's already in order, so 3, 2, 1, none. No gaps, so I can just dump that in here if you're a long divider. Remember, long division is for people who are going on in math for sure. And then the divisor sits here. And I'm going to take this space, probably up here, and I'm going to do all my division. So I'm going to take this piece of information under the dividend and divide it by the x, but not the x plus 1, so just the x, and get myself an answer, and take that answer and put it up here for the quotient. And then I multiply that by both of these, setting them in the proper column below. So x squared times x is x cubed. This makes me very happy. And x squared times positive 1 is positive 1x squared. And then we will subtract. And these subtract out, so we have 0 of them, which is kind of the point. And then 3x squared minus 1x squared is 2x squared. Bring down the rest of the stuff. So everything all columned nicely this time. Next step, take the new dividend and divide it by the first part of the divisor. And that will be 2 And x squared divided by x is x. And I can put that with its appropriate sign in the quotient area and then multiply around. So 2x times x is 2x squared. Yay me. 2x times 1 is positive 2x. Everything's nice and columned. These make 0, x squared. Negative 5 minus 2 is negative 7x. Bring down the 4. So last thing to do, negative 7x, new dividend, divided by x. X's will cancel out. We're left with negative 7, which goes into the quotient position. Multiply around, and very carefully, because of the negatives, subtract. So these subtract out. 4 minus negative 7 is 11 for the remainder. So I end up with a remainder theorem, with a division statement of x cubed plus 3x squared minus 5x plus 4 is equal to, I divided in x plus 1 because I was asked to, got x squared plus 2x minus 7 with a remainder of positive 11. Now, just to go over synthetic division, for those of you who've chosen that, remember there's your big capital L. 1 x cubed, 3 x squareds, negative 5 x's, 4 numbers, drop the 1, and the opposite of this, so x plus 1 equals 0. Solves to become x equals negative 1, which sits out here. Multiply, add. Multiply, add. Multiply, add. And a reminder how this works. This was 1x cubed. This was squared. This was x. This was constant. So it was descending order, no gaps. That makes this x squared. This one less, so x. This one less, so a constant. That is, in fact, the bracket that I got from long division. And the remainder is the same. The other two pieces should fall into place because they were given to you in the question. Now, what I want to do is I want to kind of link in the remainder slash factor theorem. So we already know that the remainder for this is 11. That means that I'm showing you the remainder theorem because it's got a real live remainder. If the remainder was 0, I would be showing you the factor theorem. So the necessary steps here, and I've got all the information I need in this statement just to remind me. First step is you have to take the dividend and call it something. So we're choosing to call it f at x. You could call it g at x, h at x, p at x, q at x, whatever your choice is. But what that does is it lets you take the divisor, set it equal to 0, which I already did if I was in the synthetic divider, solve, and put that number in for all the x's. Now make sure you do it with brackets, ultra important, because it's a negative. And then this is just an instruction to say we took all the x's and turned them into negative 1s. So I'm going to use BEDMAS. which has to be done. However, most of you probably have calculators where you can literally type it in just as you see it and spit out an answer. So negative 1 cubed for me is negative 1, plus 3 times negative 1 squared is positive 1. Negative 5 times negative 1 is positive 5, plus 4. So negative 1 plus 3 plus 5 plus 4 is equal to 2, 7, 8, 9, 10, 11. That is the remainder when you take this polynomial and divide it by x plus 1. So if you want to know if something divides unevenly, you don't have to keep trying with synthetic or long division. You can just dump in a number and test it quickly. So I'm going to label this as the remainder theorem. So I'm going to take a little break, only because my hand is cramping, and I'll be back in a sec. Remember, you can pause whenever you want. Okay, so I've set this one up so you didn't have to witness my hand cramping, although you'll probably do it anyhow later on in the question. I have taken the higher degree polynomial, the dividend, and I've called it f of x. And then I've taken the divisor, I've set it equal to 0, solved for x, and then I'm saying I'm going to put that negative 1 in for all the x's. So I'm about to do that now. So the whole object of this question is to find the remainder, and you're totally okay to find the remainder by long dividing these two, or you're welcome to find the remainder by synthetic dividing, but I'd rather use just plain old grade 9 BEDMAS. It's also a little environmentally friendly. And I don't care about the answer, I only care about the remainder. So this is negative 1. I'm going to do it a little bit quicker here. This is positive 1 times negative 4 is negative 4. This is negative 5 minus 1. So that answer is negative 11. And the answer to this question is therefore the remainder is negative 11. Now, to be clear, if I asked you to divide by something other than x plus 1, that means the number that you would be substituting in is something other than negative 1, which means you are very, very likely to get a remainder that is not negative 11. It's something else. So next question. That again is the remainder theorem. This will be the factor theorem. So we are looking for a factor. That means that we're looking for specifically a remainder of 0. So you're going to have to try to find a number that goes into all these x's substituted, and you keep searching and searching and searching until you find one that works. Until you find one that when it's substituted in gives you a 0 rather than something else. Now that seems a little bit tedious, possibly. So there is a way to narrow down your guesses. Sometimes it's logical, and there's at least one question in here where it is logical. But there's another tiny little way to take care of it, and it is by looking at the constant. The constant is the number that doesn't have any letter. So if you can find numbers that divide into 6, so ignore the negative for a second. If you can find numbers that divide into 6, like 1 and 2 and 3 and 6, and use both positive and negative versions, those are the only possibilities for you. So 4 is not going to work. If you put 4 in here, you will not get a remainder of 0. 5 will not work. 1 may not work, but the thing is, it has a chance as opposed to 4 and 5, for instance. And you certainly don't want to try anything, even 12 is not worth it because you need to make sure the numbers divide into this rather than the other way around. So I'm going to take a little bit of a break, as in pause, because I want to find the number that works. I don't want you to write down all your failed attempts. I actually want the one that works the fastest. Now, because this is a degree 3 question, there are 3 possibilities. That doesn't mean that there's actually 3. That might mean that there's 3 but 2 repeat each other. So you just have to find one of them because it says find a factor. So I'm going to struggle through this for a second without you guys watching me, and I'll see if I can find one that actually works. Found it, I think. I think it's 2. Oh, bad color. Come on. There we go. So 2, 2, 2. So it's 8 plus 8 minus 10 minus 6. There's 16 positives and 16 negatives. So I did it. So that means one of the factors uses 2. That does not mean 2 is a factor. So you have to kind of work backwards with this question and say that a bracket of x subtract 2 is a factor. One of maybe 3 of them. So what I did to get x minus 2 is I kind of worked backwards in that land that I've been using green for. So we used x equals 2 for substituting, and I went and played Jeopardy to create the bracket. So a little pause. This is the next question. Factor fully, meaning factor as much as you can. So I lied. I'm not going to pause yet. First line, indicate what your f at x is. Second line, find a number that goes in, knowing that the only possibilities are 1 and negative 1, 2 and negative 2, 5 and negative 5, and 10 and negative 10 because the constant is 10. So now I'm going to take a little break. Oh, still lied. You should be able to look at this list and narrow it down even further. And the reason I say that is I gave you a completely positive polynomial. That means if you pick any of these positive numbers and insert them in for the x's, you are just going to get gigantically more and more positive numbers as you go on. So you can try them. You're just not going to get a 0, and that's kind of the point for any time you see factoring, because factoring is the factor theorem, which is remainder 0. So I'm going to struggle on my own to try to find which one of these negative numbers works. There are possibly 3 of them. However, there could be 2 or 1 if it repeats. And hopefully there's an example somewhere in here, but there will be over the next couple of days for sure. So take a little break for a sec. You can struggle to find one yourself if you like as well. I think it's negative 2. I think that's the first one they found. Keep your fingers crossed that I'm not wasting your time. I'm trying to do that mentally. So negative 2 cubed is negative 8. That's 4 times 8, which is 32. That's, oops. Negative 34 plus 10. So here's 42 positives and 42 negatives. So I do end up with a 0. And that means that x plus 2 is equal to 0. So x plus 2 is one of the three potential factors. In case you wonder how I got that, we got this to work, and I backtracked to make the bracket. So now you have a choice. You can either choose to long divide, because we need to factor fully, so we need to find the other two brackets that work. You can either long divide x cubed plus 8x squared plus 17x plus 10 by x plus 2, or you can take x cubed plus 8x squared plus 17x plus 10 and synthetically divide. Now, I am going to take a break, and boom, all of a sudden when you come back, it's going to appear as both of them so that you can see both of the solutions, and everybody is happy, or I guess unhappy. What the heck? Come on. Oh. So, there was no tricky business, no gaps to be filled, no out-of-order polynomials. There is something to be said for long division and synthetic division. You just figured out up here with the remainder theorem, or in this case the factor theorem, because we ended up with a 0, that there is a remainder of 0. So when you do your long division, you better end up with a remainder of 0. So there's all my scribble work. There's my long division. If you choose to not do long division and do synthetic division, you're still going to end up with a remainder of 0. And if you don't, something's out of whack, and you're going to have to redo either your BEDMAS or whichever type of division that you actually chose to do. Now, based on this, I can make myself a division statement. So we've got x cubed plus 8x squared plus 17x plus 10 is equal to, we found that x plus 2 divided in, and we ended up with x squared plus 6x plus 5. Sorry, I don't have room for the green stuff here, with a remainder of 0, so you don't even have to mention a remainder here. So that would be it, except for the fact that the question was to factor fully. So if it is possible to factor x squared plus 6x plus 5, then you must do it. So this is where the grade 10 and 11 factoring comes back to haunt you from that first lesson. So can we find, this is a simple trinomial, can we find two numbers that multiply to be 5 that make 6? I'll let you struggle with that for a second. Did you find them? Two numbers that multiply to be 5 that make 6 when you're adding or subtracting are positive 5 and positive 1. What that means is that you have now factored fully. All of these are linear, meaning there's no exponents on any of them. It also means that regardless of your solution, you will end up with these three brackets. Not necessarily in the order we have them here, but you will end up with three brackets. So if I go back up to the original question, I found that -2 worked. That was my first go-to. I could have also found that -1 was a solution. Another possibility would be -5, because that's the opposite of the two other brackets. So there's actually three completely different solutions, three completely different divisions that you can do to end up with these three brackets. Now, if one of these brackets repeated themselves, then it would be 2, which is why I say there's three potential solutions. This one, there's three actual solutions. So I am going to leave you with this for a sec. I highly recommend that you stop. I'm going to stop. Try to see if you can find a solution. There could be 3, there could be 2, there could be only one solution for this. I'm going to write it all down and then come back at you and go through it. Remember that if there is more than one solution, mine is only one of those. So be patient. check your answer if that's going to frustrate you. Decided to come back to you a little bit quicker because I forgot to mention something. First of all, I'm going to use 2 because I found that 2 works. 2 does not always work. It's, I think, worked either a positive or a negative version the last couple of questions. It is not always an answer. It's always a potential answer because of this 18. So I listed this. The thing I forgot to mention is if you look at your constant and you start generating your list, please do not start with the high numbers. I'm not that mean. I will definitely put in an effort to, when it comes to assessment questions, I will pick some nice numbers. So you're not going to have to go through 1, -1, 2, -2, 3, -3, 6, -6, 9, -9 to get to the 18s to find that that's your answer. So I'm going to use 2, assuming I can find my pen. I'm going to use 2. And when you come back, I will have filled in the rest of this. Hopefully, fingers crossed, it does give me a remainder of 0, meaning that there's a factor. And then I will have my factoring done, my division done. I'll do both long division and synthetic division again, so that everybody has a solution for whichever version they choose to do. So I'm awfully glad I take little breaks, and the reason for that is it's amazing how many times I have to erase my scribble just so you can read my writing. So I found that 2 worked. That meant that x minus 2 is a factor, like those kind of things. In case you need a refresher on that, we ended up finding 2 work. So if you backtrack, you get that, and that's the factor. That means that if you are a long divider, you put x minus 2 out front and your dividend here. If you are a synthetic divider, you actually use the 2 out front because it's the opposite number from the bracket, and you put the digits of your divisor here. In both cases, there were no tricks, meaning there were no gaps to fill, and it went nicely downhill. So the degree 3 term was first, then the degree 2, then the degree 1, then the degree none. So here is my long division. Yay, I ended up with a 0, which is exactly what the factor theorem said. Here's my scribble in case you need it. Here is the synthetic division. I ended up with a remainder 0. This is a relief. This also, for me personally, I do both of them because, number one, I need to know both of them as a math teacher, but second of all, this guarantees that both of these and that are matching, and I don't proceed with screwing up, and I do make careless errors like the rest of the world. So here is my division statement. So here's the dividend, the divisor that we found in this case. That's how we've moved on. And here's the quotient. No remainder, so no mention of it. And if I go back to the very, very top, it says factor fully. So this bracket that I created with my long or synthetic division needs factoring if it can be factored. So this is a complex trinomial. That means you have to either do decomposition, which means you would have had to review it yourself or review it with me. I am going to do the scribble method. So I need to find 2 numbers that multiply to be 2 and 2 numbers that multiply to be 9. Crisscross and multiply. And I can make the positive 3 that's in the center that I skipped over by making this positive and this negative. So the negative slides into my top and the positive slides into my bottom. Here is a bracket and here is a second bracket. So my final line of the division statement is the bracket of x minus 2 that I found as a factor. I never would have found this one because if I do the quick solving for this, it ends up as x equals 1.5, and I'm not sure that you want to check all the decimals. You might have a second solution if you had have found that x plus 3 worked. So this one, in fact, had 2 solutions that are likely and one that was very unlikely. But this is my therefore statement. This is factored fully. This is the end of the note as it is on, like as we did in class. I may or may not have gone on to do this question. I'm going to do it after a quick break. This is all the stuff for the remainder and factor theorem. I believe this is the remainder theorem. This is the factor theorem. I will put online somewhere a much shortened version of this. You do not need all this practice. It is available, but you don't need it. So I will focus on what you really need to focus on yourselves. So I'm going to take a little page break, and I'll do this question right here in a sec. So reminder that I'm taking breaks, so that means you should take breaks. So I still haven't fixed any of that homework stuff up above, or suggested questions if you prefer that. What I did do is I started these questions, or the setup of this question. So I called this my f at x. If you did that, I hope you recognize that this f at x has two letters in it. It's got the letter x, which you are very used to, I hope, and it's got, or will get very used to, and it's got the k. Then I took the x plus 2, and I hope you don't need this, but it's really nice if you're trying to be careful. I took the x plus 2, which is what we're being asked to divide by, and I solved, and I get x equals -2. So that means I'm going to put -2 in for, and I'm going to yell at you here, all the x's. Do not replace the k. So I'm going to do that right now. And I've done that without really reading the question. So I'm going to read it now so I don't do anything publicly silly. So if the polynomial is divided by x plus 2, the remainder is 1, we need to figure out the value of k. So I'm going to keep going and make this as pretty as possible. So that's -8. This is k times 4, so I'm going to say 4k minus 4 plus 3. I can make this look even prettier. So 4k, -12, -9. So this is the remainder. Now it doesn't say anything about factors up here, so I know the remainder doesn't equal 0, but there must be some information in here that tells me what the remainder actually equals, as opposed to sort of equals. And it said here that the remainder is 1. So I can take this remainder, my incomplete version, and I can make it equal to the remainder that it's supposed to have. And in that way, I should be able to solve for k, because it's the only letter in an equation. Now there's something to be said here, and that is if you have an answer of 10/4 for k, I cannot give you full marks. That isn't wrong, it's just not complete. So in order to finish this, you either have to choose to turn that into a decimal or reduce your fraction. So I'm going to say that's 5/2. You could say it's 2.5. Please do not use 2.5, because you would never see a 2.5 sitting in like that in a polynomial. You would either see the 5/2 or you would see a 2.5. So I am going to erase this. I'm going to go back up just to check the question for a sec. It says determine the value of k. So I'm going to make a nice neat little therefore statement that says therefore k equals, and I'm a math teacher, so I'm picking the fraction version. So we have that. So this is your remainder and factor theorem note. The next note needs you to know how to factor fully, because we are moving on, but not on very far. So a reminder to you about that, I guess. Not a reminder, a statement. So, sorry for the boring. This is math. I'm doing the best I can.